Hello dear student, myself Santosh Bariyar Singh, PGT Computer Science.
Using a simple pendulum, plot LT square graph and hence find the effective length of the seconds pendulum. This is your experiment number 6. The apparatus required are a spherical metallic bob with a hook, 2 meters long thread, we need that, a split cork, clamp stand, slide caliper, stopwatch and a meter scale. So here you find there's a meter scale, there's a slide caliper, there's a bob with a hook, I'm showing you, bob with a hook, and there is about a 2 meter long thread, and there is a split cork which is fixed in a stand, vertical stand, and you have a stopwatch. This is the simple oscillation, simple harmonic motion which is shown, the diagram that is to be drawn on the left side of your record. Now the theory part. Before I explain, first let us define what is a simple pendulum. A simple pendulum is a heavy metallic bob which is suspended by a frictionless weightless thread and capable of to and fro motion. That is simple harmonic. And what is the difference? Why do you have a compound pendulum also? But here in a simple pendulum, the point of oscillation is here and the point of suspension is down below. You cannot interchange the point of oscillation and the point of suspension. This is a simple pendulum. But it's a compound pendulum, this is the compound pendulum. Here, the point of oscillation and suspension can be interchanged. But in a simple pendulum, you can never interchange the thread as well as the bob. You cannot suspend the bob and allow the thread to be performing simple harmonic motion. Now it has several laws here. Now, before we go over to the laws of simple harmonic motion for the pendulum, let's see what is the effective length of the simple pendulum. The effective length of the pendulum is the distance from the point of suspension to the center of gravity of the bob. Ma'am, please put it down. The total distance from the point of suspension to the center of gravity of the bob. If L is the length of the thread, if H is the height of the hook and R is the radius, L plus H plus R will give you the effective length of the pendulum. And what is the working formula for the simple pendulum? T is equal to 4 pi square L by T square. That is, you can say that, G is equal to, this doesn't mean G is equal to, wait just 1 minute. Let me just put it here. G is equal to 4 pi square L by T square, where L is the effective length in the pendulum, T is the time period of the simple pendulum. Now the simple pendulum is a heavy metallic bob suspended by a frictionless weightless thread capable of performing to and fro motion from its mean position. That is the simple harmonic motion. Effective length, as I showed you, it is the distance between the point of suspension to the center of gravity of the bob. This is effective length is always denoted by capital L in centimeter. This is height of the hook plus the radius plus the length of the thread taken. This total will, let us take a total as a whole number. This R plus H is to be determined using a slide caliper. Suppose it is 1.2. Then if you want the effective length of 120, please subtract 120 from 1.92 from 120. What will you get? 118.08. Can you measure 118.08 in a meter scale? No. The meter scale has a least count of 0.1. So you will take 118.1 instead of 118.08. Mind you, this R plus H is very important. Keep it till that second decimal place. Then, if you want a whole number of the effective length, subtract this R plus H, which is 2 decimals, and from this 120 whole number or 100 or 110, whatever you have taken, and then get the length of the thread taken. And that once you have taken that length L properly, your time period will be correct, because effective length once is correct, then you change it by 10 centimeter. So what is important here? R and H. R and H. So before we go to the measurements, then we will say, what is the time period? When the simple pendulum is oscillating, the time taken to complete one oscillation is called the time period. And what is amplitude? Amplitude is the maximum displacement from the main position. This is called the amplitude. What is the seconds pendulum? Your aim is seconds pendulum to find out the length. So in the seconds pendulum, a pendulum whose time period is 2 seconds. That means it will, for 20 oscillations, it should be covering around 40 point something or 41 within that region. So it will be time period is 2 seconds is called a pendulum. Effective length of the second pendulum exact value is 99.2. So this has to be mentioned in the theory. Now plotting L along x and t square along y axis, you get a straight line curve, a straight line graph that will pass through origin. And the slope multiplied by 4 pi square gives you the value of g. Now you should always in the theory, you should mention L and t square. L in cm and t square in second square, you must show that this inverse slope L by c square. So the inverse slope multiplied by 4 pi square gives you the value of g for the simple pendulum. So analytically, whenever you are writing the theory part, just show the trend of the graph, how it goes from L in centimeter, t square in second square. Then the law of length. These are to be mentioned in theory. What is law of length? The law of length is, the condition is for a simple harmonic motion, the amplitude of the oscillation should be restricted to 4 degrees. The small amplitude to be taken for a simple pendulum. So, then only to remain simple harmonic, otherwise there will be a lot of damping forces, air frictional drag. So, you will no longer remain simple harmonic, but acceleration proportional to displacement for spin position. So, you can say that the time period of the simple pendulum is directly proportional to the square root of the effective length of oscillation, provided the amplitude is small and restricted to 4 degrees. What is the law of mass? The time period of the simple pendulum is independent of the mass of the bob, provided the amplitude of oscillation is small restricted to 4 degrees. That means time period is independent of mass. Suppose you are given a problem that in the end you are given 2 balls. Plot L t square graph and find out g. That means g should come nearly correct. Because whatever may be the L, correspondingly you will get t square, delta L by delta t square inverse of the slope multiplied by that will give you the value of g. So the law of mass, that means time period is independent of mass. The law of isochronism, which is law of amplitude. The time period of the simple pendulum is independent of amplitude of oscillation, provided, what's the condition? That the amplitude is small, restricted to 4 degrees. Then comes the law of gravity. The time period of the simple pendulum is inversely proportional to the square of the gravity of the place, provided the amplitude is small, restricted to 4 degrees. Mind you, this line, provided amplitude is small, restricted to 4 degrees, has to be mentioned in all the laws because it's a simple harmonic motion. Procedure. The diameter d of the bob is determined using a slide caliper. Bob showed the bob and the slide caliper, you determine the diameter using the slide caliper. Same table, least count, MSR, VC, VSR, total. So the diameter has to
3 observations are now, and they are very practically.
and then diameter the first table.
Diameter comes to be around 1.90.
Okay. Then second observation table, determination of D plus H. This determination of D plus H, which is actually, this should be capital D because we have taken a capital D for the diameter, determination of D plus H.
Bob and one will take between the
Show that, show it. D plus H, that comes to 2.4.
Bob and hook together will be kept between the just and D plus S to measure 3 times.
I have taken it as 2.418 here. Taken it as a mean, 2.418. Now, if you calculate the radius, that is, you subtract from from this second table, you subtract the radius calculated from the first table. Where is that diameter calculated? Here. In the diameter, you have calculated the radius 0.498. Now, this is 0.498 is the radius calculated from the table 1. You have just placed the diameter, length, the diameter wise. Then D plus H from the table 2. Subtract this 0.498 from 2.418. That comes to 1.92. That comes to 1.92. That is your R plus H. Now, I just told you while explaining it, if you take a 120 length thread, you have to subtract 1.92 from 120, it will give you 118.08. You cannot take 118.08 because the least count of the main scale is only 0.1. So this is more than 5, so it can be taken as, if it was 0, 2, you would have taken only 118, this is 118.0. If this value was 118.02, what would you have remembered the length of the thread taken? 118.0. Is that clear? The rounding off will be done only on the meter scale, the length of the thread taken. Nowhere else. The D plus H, measurement of R plus H will always have a second decimal place. Okay? The mean can have 3 decimals, but when you take it out, R plus H, you can have a second decimal because you have used a slide caliper which is accurate up to the second decimal. Then, suppose you want a 100 CM. 100 minus 1.2, 1.92, what is the value? What is the value? 98.08. Can you take 0.08? No, it will be 98.1. So once you have taken the largest length 118.1, just decrease the length by 10, 10, 10. So it will be 120. Next will be by 10, it will be 108. Here it is 110. Another 10 centimeter decrease, you will get 100. Then you will have 88.1, it will be 90. You will have 78.1, it will be 80. You have 68.1, it will have 7. So you go on decreasing by 10 centimeter and you will get different. But for every effective length, time for 20 oscillations, have to be calculated. Time for 20 oscillations have to be calculated. So here T1, T2, T3 seconds. These are 3 times you have to calculate. So I will only show the oscillations.
Now the bob was alert almost at the mean position. We say how will it complete one oscillation? When it starts from mean position, goes to one extreme, then comes to mean position, again back to other extreme and comes to mean position, we say that it has completed one oscillation. Starting from mean position to one extreme, then to the other extreme, then back to mean position. One oscillation is complete. And the time required to complete one oscillation is said to be time period. And to reduce the error, we will measure the time for 20 oscillations.
Ma'am, it will be much more easier if they start the calculation. Just allow it to oscillate for some time. Switch on the stopwatch when it comes to the left. It goes to the mean to the extreme left, comes back to the one oscillation. From left to this right and comes back to the one oscillation. That means from left to right and back to left, one oscillation. That will be much more easier for the child to switch on. Let the 4 oscillations go away. You switch on when it comes to the left. On 1, 2, like that.
So that means it will cover the path twice. So it is better to
Passes
start
to
from
mean.
one.
From extreme to each.
Yes. It is better to start from one extreme position and
Yes. Allow it to go through twice through that.
so we will allow
To the mean
to
position.
oscillate and we will take care that it should not rotate.
Yes, spinning the one should not be any spin.
And we will keep in mind that the angle of oscillation should be around 4 degrees so that it will
This is wrong.
cover a path around here. Marks are given at a distance of 6 centimeter. The amplitude should be very less. Okay, oscillate and we will start from one extreme position, suppose here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it has covered around 43.84 centimeters.
So seconds.
84 seconds. 43.84 seconds.
Okay, so we have done it initially. We'll take it with another bob and find out again a reading for you. But this is 3 times we had calculated 43.84, 43.81 and 43.87. So you get the mean time for this will be again will be 43.84. Now the time period, what is time period? Time, it will be time for one oscillation. These are all for 20 oscillations. This is mean time for 20 oscillations. So divided by 20, you will get this value, which is your 2.192. So take the t square of it, which is 4.804. Then take the L by t square for all these values. It will be 120 by t square. Here this is again for 110, you decrease it by 10. You will get all these readings. Then again the mean time period divided by 20, you will get the time period. This is mean time for 20. Again time period for 110. Then time square for the 110. Then 110 by this square. This was 120 by this square, that is this value. So you get L by t square here, all this. Actually what we do is L by t square for all, then we calculate mean L by t square and G is 4 pi square into mean L by t square. In some experiments they do it like that. But I just wanted to show you that if you calculate the G value for this particular observation, you must be very careful when you are doing, you must see whether you are getting the G value around 988, 898, because G value will not be 980, but it will be somewhere in this value. So you will see that this is coming as calculation. This gives you a very close to that value. So it is 986.138. Okay. So it is it's not necessary that you calculate G for each one. No. You will calculate L by t square. Then mean L by t square multiplied by 4 pi square gives you G. But the aim of your experiment is plot a t square graph. Then from the graph you can calculate G slope method, but hence find the effective length of the seconds pendulum. What is the seconds pendulum? Whose time period is 2 seconds. That means this column, the t square value is 4. This is 4.027. Here it is, what is the value is coming? 98. But what did I write there? Actual value 99.2. Okay, so let's see whatever may be the value. So result is accessed due to gravity by simple pendulum is mean L by t square into G. That is from the observation table. You can also calculate L by t square, that is L by t square from the graph by the slope method, and then multiply 4 pi square G graphically. So you'll have two values: observed value of G from the observation table and graphical value of G from the graph. And then so multiplying 4 pi square with slope inverse gives you G from graph. In the graph, x coordinate for t square equal to 4 secant square gives the effective length of the seconds per minute. See here, that is you have plotted here. This is your length and the t square, and the t square value where it is 4 here, 4 value is half. This is slightly not legible, so you can calculate the length of the seconds pendulum from there. Okay? Wherever you need not take 4 value, but where in here, from here, take the corresponding x coordinate. It comes around that 99 or 90, around that, within that region. Okay, so you will write that, and right there, if you want to actual value is 99.2, I got this value, so difference in multiplier, so you get a percentage of the factor. Precautions: the d plus h and r should be determined accurately. Why? Because r plus h is the deciding factor for the value of g. Now, because if L changes, your time period will change. Why? Because your time period is directly proportional to the square root of effective length. Amplitude of oscillation should be small because otherwise it is not simple harmonic. Time for a period for 20 oscillations should be taken carefully.